So class, we're asked to differentiate each of the following functions. Find dy dx if y equals to n x raised to the power minus 3 over 2. Find dy dx if y equals to 2x root 2 minus x. Find dy dx if y equals to the fourth root of x. Find dy dx if y equals to root x or to bracket x minus 1. Find dy dx if y equals to sine 2 theta minus pi over 4 with respect to theta. And find dy dx if y equals to sec squared x. Class, we'll start from the first question, number 1. The y dx. Class, I want you to recall that anytime you see n of a function, anytime you have to differentiate n, let's use the simplest function x. Just to remind you that in x, if you simply differentiate x, you're going to have 1, and repeat x under 1 all over. So anytime you have to differentiate n, which is natural logarithm, which means natural, anytime you have to differentiate natural logarithm of a function, class, you have to differentiate the function and put it as the numerator, while the main function will remain as denominator. You have to differentiate the function x and let it be your numerator and repeat x below as denominator. So differentiate x, you have 1, then repeat the question under 1 over x. So applying this rule to this, we have to differentiate this guy and put him up, then repeat whatever is there below. So let's try differentiating x raised to the minus 3 over 2. Class, x raised to the minus 3 over 2, we can assume that it's an divisible one here, coefficient. So that we can have a coefficient. Class, when differentiating, multiply your coefficient and your power. 1 times minus 3 over 2 is what? Minus 3 over 2. Repeat your base, x, subtract 1 from the power. Minus 3 over 2 minus 1. Minus 3 over 2 minus. Minus 3 over 2 minus 1 looks like minus 5 over 2. Minus 5 over. But let us do it. Minus 3 over 2 minus 1. Because you subtract 1 from the power. Subtract 1 from the. So minus 3 over 2 minus 1. Oh, let's call this over 1. LCM is 2. 2 in 2 you have 1. 1 times minus 3 is minus. 2 in 1 you have 2. 2 times 1. Minus 3 minus 2. Minus 5 all over. So this shows us that minus 3 over 2 minus 1 is minus 5 over 2. Now divided by the question itself, which is what? X raised to the power minus 3 over. Class, at this point you're actually done differentiating, but you will not see, I can bet you that you will not see your options exactly like this. As long as after differentiating there's something you can further do to the question you answer, make sure you do it, because you will never see this in the option like this, I bet you. First of all, what can happen here is this x minus 5 over 2 can come down. Minus 5 over 2 can come. And minus 3 over 2 can go up. Funny enough. Class, when minus 5 over 2 comes down, it becomes 5 over 2 without the minus. And when minus 3 over 2 comes up, it becomes 3 over 2 without the. So we're actually going to have x raised to the power 3 over 2 up and x raised to the power 5 over 2 down. So actually, if you follow the rule, you are done differentiating here, right? But if there's something that can still be done to your answer, you first check if this is the option. No. Ask yourself, can something be done to the answer to be simplified? Yes. Go ahead and do it. That's why you're not seeing your answer in the option. So it's not enough to just know how to differentiate. Pay close attention to what has been done to your answer, then you're not seeing that what you did in the option. Because if you finish differentiating, you got this, and you're not seeing this in the option. Don't just assume that you did something wrong, but the question is wrong. Go back and look at your answer. Is there something that can be done? Yes. This minus, if it comes down, this minus will disappear. It's a law in mathematics. That when someone has a negative power and this power changes position from numerator to denominator, the power will change to the opposite sign. If it was minus, it becomes plus. If it was plus, it becomes. And this guy that is minus, when it goes up, it becomes plus, class. So these two just exchange position and they are minus goals. And this can still be written as minus 3 all over 2. Class, 3 x raised to the power 3 over 2 is written as the square root of x all raised to the power 3. The square root of all raised to power 3 plus is called fractional index law. In mathematics, this is called fractional index law. Anytime your index is a fraction, your numerator becomes the power, your denominator becomes the root. Your numerator 3 becomes your denominator 2 becomes so you see square root 2 means square root means second root. Square root means second. So second root of x raised to power 3 all over. Same thing happens in fractional index law. Your denominator becomes the root, second root of x, and your numerator becomes the raised to power 5. So x raised to power 5 over 2 can be written as second root or square root. Another name for second root is square root of x raised to power 5. Class, before we even do this, do you know that something can even happen between this x and this x? In the law of indices, when dividing two bases, you can pick one base and subtract their power. Do you agree? This is minus 3 over 2, x raised to power 3 over 2 minus 5 over 2. Do you agree? X raised to power 3 over 2 divided by x raised to power 5 over 2 is x raised to power 3 over 2 minus. Because class, x raised to power a divided by x raised to power b is x raised to power a minus. Pick one x and subtract the. It's called quotient law in this. It's called quotient law in what? Your law of indices, you have 10. You have product law, you have quotient law, you have negative power law, you have fractional index law, you have negative zero law, you have zero law. There are 10 law of indices. One of them is called the quotient law. Plus, anytime you have two indexes with the same base, this x, this is also x. They are the same, but they are dividing each other, they are dividing each. Pick one of the base and subtract the power. That is this law that allows us to pick x and say 3 over 2 minus 5 over 2. Now what is 3 over 2 minus 5 over 2? LCM is 2. 2 into 1, 1 times 3. 2 into 1 times 5. 3 minus 5. Minus 2. Minus 2 all over 2. 2 cancels to remaining minus. So all are short of everything here is minus 3 over 2 x raised to power minus 3 over 2 x raised to power minus 1. Which is now, can x and minus 1 come down? Minus 3 over 2x raised to power 1, right? The minus will no longer be same thing as minus 3 all over 2x. Final answer. So class, everybody can differentiate to stop here. But who is good enough in maths to resolve your answer to this? It's the person that can bring this answer to this that will get the full mark. This person will be lost looking for this in the option, you will not see it. For class, if you want to be truthful, after differentiating this is your answer, right? Any other thing you do here is not differentiating, it's simplifying your answer. You have to answer. Or what? Class. What department? Who going to CSE by 12? What is 3 now? Square. Every day looking for ways to just confuse students. Where is he holding? This computer science. Is the lecturer there? Confirm for you. Is the lecturer there? You can't find that. You have just got on. Sometimes you can't be smart in this school. Eh? So you can see that if you differentiate, you've got your answer here. But you are not seeing this in the option because this answer can further be simplified all the way down here. Let me come again one more time. We have to differentiate y equals to a x raised to power minus 3 over 2. We don't have to put 1 here, class. Anytime x is standing alone, class, you are allowed to put 1, and the divisible 1 is always there. That's standing as the coefficient. There's an divisible 1 that is standing as the what? If someone is carrying x squared, just know that you can say 1x squared. If someone is carrying x raised to power 5, you can say 1x raised to power. If someone is carrying x raised to power minus 3 over, you can say something as 1x raised to power minus 3 over. 1 is the easiest person to add to any function because 1 times 5, 5, 1 times 10, 10. 1 does not change to someone. Introducing 1 here plus to recognize our coefficient base and so 1 is the coefficient, x is the minus 3 over 2 is the, because to easily differentiate, if you can see your coefficient base and power, it's easier to differentiate. Because I told you, every time you have a natural logarithm function, like in means natural logarithm. This function means natural. Anytime you see in and they say differentiate whatever, 3x plus 2. I'm using a simpler question now. In 3x plus, class, the rule for natural logarithm differentiation is that differentiate the function in front first. Differentiate 3x plus 2, you're going to have 3. Because differentiate 3x is 3, 2 is a constant, you now say all over repeat the 3x plus 2 on that. 3 all over 3x plus. Class, this is the differentiation of in 3x plus 2. And this is what you should do to all natural logarithm differentiation. This is what you should do to all natural logarithm differentiate the function in front, put it on top. Then repeat the function like that, undifferentiated below. That's the rule, that's the what? Let's apply it in the main question now. So the main question is in x raised to minus 3 over 2, which is 1 x raised to minus 3 over. Differentiate this 1 x raised to minus 3 over 2, put it on. Then repeat the x raised to minus 3 over 2 below, look at it. And normally you should be done here. But why are we going for that is if we don't see our answer in the option. What's the update? By 3. Are you seeing? I know this school so well. They would have gone now. Then answer here, that's not coming back. Confirm, before you straighten yourself, confirm, is he holding? I mean, don't straighten, I'm learning something important here. Is he holding? Even if he's holding, we don't understand anything. If they're not going to set test, I'll prepare your notes. Let me learn this thing. Class, 2 hours of learning is what 10 hours of lecture they are not understanding. 2 hours of sitting and you're actually getting something. Oh, this is scientific, I beg, let me do this for you, I'll collect the notes. Because what's the guarantee that if you go for that class, you still understand? No guarantee. But you are sure that we are coming again. See, we are still in one question since. If it's lecture, we have finished the 5 by now. We are still in one question, but I want to make you under. So please confirm, make inquiries. If I didn't tell them, maybe they will have gone and they will not come back now. Class. I know last week was 3 o'clock. Now they're saying 1. I just want to start confuse students every time. So class, differentiate this guy, put him on top, repeat the question. So how do you differentiate this guy? 1 times minus 3 over 2. Multiply coefficient and power. Remember how to differentiate now. 3 basic steps of differentiation. Step 1, multiply coefficient and 1 times minus 3 over 2 is minus 3 over. Step 2, repeat the base x. Step 3, subtract 1 from the. So that's minus 3 over 2 minus 1. Look, it's still here. Oh, I've cleaned it. But minus 3 over 2 minus 1, we find that it's minus 5 over. So this is minus 3 over 2x raised to minus 5 over 2. All over the question, x raised to minus 3 over. Everything we did outside there is no longer differentiation. It's now normal mathematics, common sense. I'm not saying this in the option. I did not something to my answer. Can I simplify? Can this guy come down? Can this guy go up? What can I do? That's what we're doing. It's no longer differentiation. That I'm explaining, I'll explain it now. Now look at this x raised to minus 5 over 2. Look at this x raised to minus 5 over 2. If it comes down, the power will change to positive. And look at this x minus 3 over 2. If it goes up, minus power will change to positive. Change to positive, but that's someone was saying go there. We didn't even check here. If this guy goes up, the power will change to positive. If this guy comes down, power will change to positive. So brief is a rule in indices. When someone is having a negative power and it changes position from down up, his power will change to positive. When this guy goes up, it changes to x raised to 3 over 2. And when this guy comes down, it changes to x raised to 5 over 2. And that's why we are right there. Why interchanges is that I wanted the minus to go in 2 of them. Of course, if you don't want to exchange their positions, let us apply the law of indices here. You can still apply the law of indices here and say x raised to power minus 5 over 2 minus 3 over. Because they have the same base, x and x, right? So pick one x, minus 5 over 2 minus. Now what is minus times minus? Plus. So this is now minus 5 over 2 plus 3 over. Let's find the LCM. 2. 2 divided by 2. 1 times minus 5. Plus 2 divided by 2. 1 times 3. Minus 5 plus 3. Minus 2 all over. 2 here cancels 2, you have minus 1. So that we still got the same thing. Minus. Is that not what we have here? Minus 3 over 2 x raised to minus 1. But why I wanted to exchange their position is that it might be more difficult to navigate the negative than the what? Than the positive. So you see how we arrive at x minus. So you see that in case you are okay with subtracting this and you don't have any problem with the negative, you can just pick one of the base and subtract their power. But if you always have an issue with negative, that was why I said let this guy go up and become positive, let this guy come down and become. And you see that we still subtract their power. X raised to power 3 over 2 minus. And 3 over 2 minus 1 over 2, we have minus. We still leaves us here anyway. And minus 3 over 2, x raised to power minus 1. When x raised to minus 1 comes down, it becomes x raised to power. And x raised to power 1 is x, right? So our final answer is minus 3 all over 2x. I intentionally picked these questions because I could have said yes. I thought on Saturday we did natural logarithm, right? I could have stopped there and said you know natural logarithm class. You can still fill the question on natural logarithm in the exam. Class, the main differentiation is just a 1 or 2 step process and you have differentiated. What will give you problem in the exam is not even differentiation. After learning all types of differentiation, what will give you a headache is that after differentiating any question, it's very unlikely that you see your answer exactly like that. There's always something you might have to do, except in few occasions. There's always something you might have to do, simplify, factorize, bring this up, bring this down, expand, do one thing or the other to actually arrive at your final. And that thing you have to do has nothing to do with differentiation, it's just normal mathematical common sense. That's why I selected each of these questions. Let's take the second question now. If you do not attend on Saturday, I will upload the video. The video is available. I will upload it. The chemistry video was so long, so it took the whole weekend to upload. So we did chemistry and math on Saturday. So I've uploaded the chemistry, remaining in math 120. Question 2. So it means I will upload the Saturday math and also this one that is being recorded now. Y equals to 2x root 2 minus s. Class, this is product of 2s component. Immediately what should come to your mind is product rule. I taught product rule in this class, right? Call the first person u, call second person. So this means that u is 2x and v is what? Root 2 minus. But class, can I write root 2 minus s as 2 minus x raised to power 1 over 2? Yes. I can, right? Yes. The square root of any function is that function raised to power 1 over 2. The square root of any function is that function raised to power 1 over 2. Class, now if u is 2x, can we differentiate u with respect to x? When you differentiate u to x, what do you usually have? The u dx. And differentiate 2x, you have what? Now let's differentiate v with respect to x. What we have? dv. Differentiating v with respect to x is dv. Class, what kind of function is this? It's function of function, composite functions. And what can bring this guy down is chain rule. What can bring this guy is what? Chain rule. The shortcut I taught you, remember? Bring down the power, right? Differentiate the bracket, you have minus 1. Repeat the bracket, you have 2 minus. Subtract 1 from the power, you have minus 1 over. Let me take it slowly now. Let me call. Bring down the power 1 over. Have I taught shortcut to something like this? Yes. If you have missing classes, you will just be lost when you come any day. X minus 2x minus 5 raised to power 7. Differentiate. Functions like this that are into brackets and power is after the bracket. When you have a function in the bracket and its power outside the class, the rule is a shortcut to differentiate questions like this. Nothing like question and power here. Class, the first step is bring down the power 7. Bring down the power what? 7. Second step, differentiate what you have inside the bracket. Differentiate 2x, you have minus sign is the constant, disappears, right? Third step, repeat the bracket 2x minus. Last step, subtract 1 from the power. One more time. Bring down the power 7. Differentiate what you have inside the bracket. Repeat the bracket. Subtract 1 from the. This is how you differentiate functions like this. So that you end up having 7 times 2. 14 into bracket 2x minus 5 raised to power. Class, this is how to differentiate functions like this. So class, it's the same thing we're going to do for 2 minus s raised to power 1 over 2. Bring down the power 1 over. Differentiate what you have inside the bracket. 2 is a constant, disappears, right? But differentiate x is 1, but there's a minus before x, so it will be minus 1. The differentiation of s is, but there's a minus before x, that's the problem. If there was no minus before x, it would have been 1 here. But because it's minus x, therefore it's minus. Are we together? So coming again, bring down the power 1 over 2. Differentiate the bracket, you have minus. Repeat the bracket 2 minus. Subtract 1 from the power. 1 over 2 minus 1 is minus 1 over 2. Let me show you. 1 over 2 minus 1 over 1. LCM is 2 divided by 2, 1, 1 times 1, 1. 2 divided by 1, 2, 2 times 1. 1 minus 2. Minus 1 all over. So that 1 over 2 times minus 1 is minus 1 over 2. Into bracket 2 minus x raised to minus 1 over. Can this guy come down? Anytime someone is carrying negative power, it can come and become minus 1 all over 2 into bracket 2 minus x raised to power 1 over. The negative power no longer be there, right? It has changed position from up, down. It has changed position from what? And class is setting as minus 1 all over 2 roots. Because 2 minus x raised to power 1 over 2 is setting as root 2 minus. Anybody raised to power 1 over 2 is square root of that person, right? Anybody raised to power 1 over 2 is square root of that. And class, this is the V ds, this is the V. Once you've gotten your U, you've gotten your du dx, you have gotten your V, you've gotten your dv dx, you can now apply the rule for product 2. The formula for product 2 says that what? The y dx equals to u dv plus v du. The formula for product 2 tells us that what? U dy dx. The formula for product 2 tells us that dy dx equals to u dv dx plus v du. U dv dx plus v du. Where this bracket. How can what do you want to use 1 over 2? How do you want to use 1 over 2 to expand the bracket? These two cannot open this bracket because it's a power of 1 over 2 here. So this 2 has no right to open a bracket that has not been resolved because it has a power. This bracket is not just on its own, it has a power of 1 over. So you cannot use this 2 to expand the bracket because this guy is not resolved. Do you know the value of 2 minus x raised to power 1 over 2? No. So how can you not introduce this 2 into it? You are not allowed to. You are not allowed to do. So the y dx is u dv dx plus v du. Who is u? 2x. U is what? Who is the v dx? The v dx is what we just have here. Minus 1 all over 2 root 2 minus plus v. Who is v? 2 minus x. V is root 2 minus x, which is 2 minus x from 1 over 2, right? V is root 2 minus. You can either call it root 2 minus x or 2 minus x from 1 over. But I prefer to call it root 2 minus x for now. It's when I want to differentiate that I usually like it to be 2 minus x raised to 1 over 2. So I can easily differentiate. Who is the u dx? 2 multiplied by. I'm just applying the product 2 formula u dv dx plus v du dx. Class. If you look at this, 2 on top here can cancel 2 below here. X times minus 1 is minus x all over root 2 minus x plus 2 times root 2 minus x is 2 root. This 2 has no reason to enter into the square root, right? So 2 minus x times 2 is 2 root 2 minus. This is all over 1. Let's find the LCM. Root 2 minus x times 1 is root 2 minus x. Root 2 minus x divided by root 2 minus x is what? 1. 1 times minus x plus root 2 minus x divided by 1 is root 2 minus. Root 2 minus x times root 2 minus x is 2 minus x times 2. This is 2 into bracket 2 minus. When multiplying two sorts of the same element, the answer is the element, remember? Minus x plus 2 times 2. 4. 2 times minus x minus 2 all over root. What is minus x minus 2x? Let's put the final answer here. Minus x minus 2x minus 3x, but there's 4 there, right? That's 4 minus 3x all over root 2 minus. Final answer. That's if you don't want to rationalize. That's if you don't want to rationalize. Let's come again. Please follow carefully, please. Y equals to 2x root 2 minus x. As soon as you cite a question like this, x occurring here, x occurring here. This is a product of two different components. This is 2x and this is root 2 minus x. These are two different. What should come to your mind straight ahead is that call the first component u, call the second component v. So u equals to 2x and v therefore equals to root 2 minus. But root 2 minus x is the same thing as 2 minus x raised to power 1 over 2. Root 2 minus x is the same thing as what? 2 minus x raised to power 1 over 2. So if u is 2x, let us find differentiate u with respect to x. You have the u. And what's the u dx? 2. What's the u dx? 2. Alright. Call the first component u. Call the second component what? V. The u dx is 2. The v dx, this is where the plan starts. Follow carefully. Bring down your power 1 over 2. Differentiate what you have inside this bracket. You have minus 1. Repeat what you have inside the bracket. 2 minus x. Subtract 1 from the power. 1 over 2 minus 1 is minus 1 over 2. Look at it here. 1 over 2 minus 1. I even showed you. Find the LCM. You have minus 1 over 2. What we will now do is that 1 over 2 times minus 1 is minus 1 over. This is the 2 minus x. 2 minus x. Follow. Now, this is the minus 1 over 2 here, power. This whole 2 minus x raised to minus 1 over 2 will come down and become 2 minus x raised to power 1 over 2. But this 2 minus x raised to 1 over 2 can be returned back to the square root form of root 2 minus without affecting these 2 outside. Look at these 2 outside, it's still outside. I just changed 2 minus x raised to 1 over 2 to square root of 2 minus. And my final answer for the v dx is minus 1 over 2 root 2 minus. After getting u and the u dx, v, the v dx, apply the product rule formula. Because all along we knew that this was a product rule question. Call this u, call this v. And according to product rule, the y dx equals to u dv dx plus v du. Who is u? U is 2x. Who is the v dx? Minus 1 over 2 root 2 minus x. Plus who is v? V is root 2 minus. And who is the u dx? 2. Now you see 2 up, you see 2 down. 2 can cancel 2 up. Leaving you with x, but x times this minus 1 is minus all over. Who is remaining down? Root 2 minus. Plus 2 times root 2 minus x is 2 root 2 minus. These 2 cannot affect anybody inside the square root. We just come and be behind. So you're now left with minus s over root 2 minus s plus 2 root 2 minus s all over. We then took the LCM as root 2 minus s times 1, root 2 minus. Root 2 minus s divided by root 2 minus s is what? 1 times minus x. Plus root 2 minus x divided by 1 is root 2 minus x. Times another root 2 minus x. Root 2 minus x times this root 2 minus x is just 2 minus x. Without the square, without the square. Root 2 minus x times root 2 minus x is 2 minus without the square root. Root 5 times root 5 is 5 without 5. Without the square root, sorry. When multiplying two sources of the same element, the answer is the element without the source, without the. But there's 2 here, remember. Now, in this kind of situation, these 2 can expand the bracket because this 2 minus x is not carrying any power, right? So this 2 has the power to expand the bracket. I'm recording the class, please. So we're going to have minus x plus 2 times 2. 4. 2 times minus x. Minus 2x. All over root 2 minus. What is minus x minus 2x? Minus 3. So you're left with 4 minus 3. All over root 2 minus x. Question 3 says y equals to 4th root of x. Class, you can't solve this question until you realize that the 4th root of x is written as x raised to power 1 over. The 5th root of x is x raised to power 1 over 5. The square root of x is x raised to power 1 over 2. The cube root of x is x raised to power 1 over 3. It's a rule in mathematics. Please take. So the 4th root of x is x raised to power 1 over 4. Class, there's an invisible 1 here. So that the y dx, 1 times 1 over 4 is 1 over, repeat your, subtract 1 from the power, 1 over 4 minus 1. LCM, 4 in 4, 1 times 1. 4 in 1, 4 times 1. 1 minus 4. So 1 over 4 minus 1 is minus 3 over. But x raised for minus 3 over can come down, right? And the minus will disappear. Are you seeing that there is no more minus? And this can be written as 1 all over 4 plus. This is the 4th root of x raised to power. Because I told the fractional index, the denominator becomes the root, the numerator becomes the final answer. This one will not stress us, Abby. This one will not stress. The next one will stress us. Class, I want you to attend the next one by yourself. I'll pause the video. Attend the next one by your. Let's look at it together. We give this as a classwork. Y equals root x. So u is root x. Call the first person u root x. And call the second person v. X minus. When you see the product of 2x component, that is call the first component u. And call the second component what? V. So u is equal to root x, v is x minus. But we all know that root x is written as x raised to power 1 over 2, right? So differentiating du dx will be, well, you can put an invisible 1 here, right? So that 1 times 1 over 2 is 1 over 2. Repeat your x, subtract 1 from the power, you have minus 1 over. Well, it's not every time they must be showing you how minus 1 over 2 minus 1 is minus 1 over 2. You just get used to it, right? Save it in your brain. Anytime 1 over 2 subtracts 1, you have what? Minus 1 over 2. But of course, you should know that this minus 1 over 2 can come down, right? And becomes 1 over 2 x raised to power 1 over 2. The minus will no longer be there, right? The minus will no longer be. And therefore, the u dx will be equal to 1 all over x raised to 1 over 2 is root x, right? So the final answer is 1 over 2 root x. The final differentiation of the u dx is 1 over 2 root. Now if v is x minus 1, what's the v dx? 1. The v dx is, for the differentiate x you have, minus 1 is a constant, it disappears. It is using the product rule, the y dx equals u dv dx. The y dx equals u dv dx plus v du. The y dx equals to u dv dx plus v du. Who is u? U is root x. Who is the v dx? The v dx is 1 all over. No, the v dx is 1. The v dx is times 1 plus who is v? X minus. And who is the u dx? 1 all over 2 root. The u dx 1 all over 2 root. Root x times 1 is root. Plus x minus 1 times 1 is x minus 1 all over 2 root. Let's find the LCM. 2 root. 2 root x divided by 1 is 2 root x. 2 root x times root x is what? 2x. Is 2. 2 root x divided by 1 is 2 root x. Now 2 root x times root x. Root x times root x is x. But there's a 2, so 2. 2 root x divided by 2 root x is 1. 1 times x minus 1, x minus 2x plus x. 3x minus all over 2 root. 3x minus 1 all over 2 root. Please write fast so we can go to the next question. How do you differentiate sine 2x? Differentiate this 2x first, right? You have 2. Sine will change to, then repeat your 2. So class, in this aspect, since we are differentiating y with respect to theta, it's going to be dy d theta, dy d. This is not dy here, dy d theta equals. Class, just like we did, we differentiated whatever is in front and put it behind. Sine change to cos, then repeat everybody in front again. Likewise, we differentiate 2 theta minus pi over 4. Differentiate 2 theta, you have 2. Minus pi over 4 is a constant, because pi is a constant. Pi has the value 3.142 or 22 over 7. Don't allow that pi to now shake. You say, hey, pi, which one be pi? How will you differentiate pi? Pi is a constant, class. So differentiation pi over 4 is 0. Minus pi over 4 is what? So differentiate 2 pi minus pi over 4 gives you only 2. But differentiate 2 pi, don't like differentiate 2x. Differentiate 2x, what do you have? 2, right? Differentiate 2 pi, 2. Minus pi over 4 is a constant, 0. Now, sine changes to repeat your 2 pi theta minus pi over final. So when you see that theta, some of you saw that theta and pi, thought there's one special thing they will do. Don't allow a very cheap question look difficult for you in the exam class. Don't allow a very cheap question look difficult for you in the. Don't allow them to put one symbol and you not shake. Hey, oh, like do, hey, calm down. If that symbol is a constant, know that all constant dimension gives you what? 0. Don't even stress your. Number 6, the last one. We have to differentiate y equals to sec square x. Differentiate y equals to what? Sec square x. Differentiate y equals to sec square. So y equals to sec square x, and sec x all. Class, sine square x is sine x all squared. Sine cube x is sine x all cube. Y equals to sec square x is sec x all. And what should come to your mind is chain rule, shortcut. Bring down the power. Differentiate the bracket. Go to that table, differentiate sec x, you have sec x times x. Do you remember? Yeah. That trigonometric table I gave you. You missed the class on Saturday, please follow up on the group. I always post it there in our paid members group. If you are fully registered and I am not on our paid members group, message me, let me add you. So class, come again, bring down the power 2. Differentiate the bracket, differentiate sec x, you have sec x and let's check the table, I gave you. Repeat the bracket, sec. Subtract 1 from the power, you have 2 minus 1. So sec x raised to power 1 is sec x. So what we're having here now is 2. Sec x times this sec x is sec x all squared. And class, you might finish this and not see this in the option, but I've seen something that can be done here. This is the final answer, but you might not see this in the option. Let me come again one more time. Class, bring down the power what? 2. Bring down the power 2. Differentiate the bracket, differentiate sec x. Check your table. Differentiation of sec x is sec x tan. Now repeat the bracket sec. Subtract 1 from the power 2 minus 1. Now this sec x can multiply sec x, give you sec x all tan with these 2. What if this is not in the option? I've seen something that can be done. Class, I want to recall that sec x because sec x also is written as sec square, sec square. Class, sec x is the same thing as 1 all over cos x. 1 over what? So sec square x is written as 1 over cos square x. This sec x is 1 over cos x. Class, cosec x is 1 over sine, and cos x is 1 over tan, and tan x is sine x over cos. Class, in trigonometry, this doesn't have anything to do with differentiation. There are some questions you will miss, not because you cannot differentiate, but because of some other small math things you don't know. That's why they always attach that 110 to 120. In Math 110, the course title of Math 110 is Algebra and Trigonometry. Check the textbook. Algebra and Trigonometry. Tuesdays and Wednesdays we have Math 110. Please don't joke with the classes. Some of you feel like you're stressing, but once you finish exam, you can rest. Then second semester starts, then you have a little break. It's just school you came for. School is IS 4 years. Do it well. That's why I say if you want to you are coming to school, plan yourself. Okay, I'm ready. Some people just delay the and say, I'm ready for school. Plan yourself is mentally, you have to prepare yourself. I'm ready this school today. I'm ready to give me my time now. So class, because after differentiating by not seeing this in the option, what happened? Someone should know that sec squares are changed to 1 over cos and tan x is sin x sin x over what? Cos x. If you look at this now, this can be written as 2 sin x all over cos cube 2 sin x all over what? Cos x times cos x is cos. It can be changed from square to what? Cube. Learn how to play with trigonometric ratios. I'll teach trigonometry in Math 110. Last week I taught partial fractions, right? When I finished partial fraction, I went at complex number. I heard there was a test in FOS, Math 110. The lecturer gave a test on complex number. I'll teach complex number very well. I will teach trigonometry. I've been taught sequence and series, AP and GP. So you have learned your own hall. Some halls have not learned it. Then your Math 110 has like 10 mathematics topics. So binomial theory. Have you taught binomial theory? Not yet. Math 110 is bulky. So Tuesday and Wednesday is Math 110. Don't joke with the class. Thank God we are done with the workbook, Abi. We did the workbook last week. That's what took our time. So this week now, Tuesday and Wednesday, we'll cover at least two topics in Math 110. Tomorrow we have Math 110. They gave another assignment in Math 110. We will not allow that one to slow us down. We can do that one separately, but we'll have class tomorrow. If it's not too much, I can just do it before I start class tomorrow. Is it much? It's much. 10 pages. Another 10 pages. This one allows us to learn. I'll find a solution to that. Let's continue first. Now write down quotient rule. Quotient rule of differentiation. Class, I've taught you chain rule. Chain rule is the one I say bring down the power, differentiate the bracket, repeat the bracket, subtract one from the dash chain. If you're here on Saturday, I even did the long cut of chain rule. Class, this method of bringing down the power, differentiate the bracket is a shortcut. There's a long method where you replace this guy with u, right? And find the y du and find the uds. Multiply the y du by the uds, you have the yds. I taught it on Saturday, the long method. But if it's for your exam sake, you will never need the long method for your exam sake. For your exam is OBJ, it's just get the answer and move forward. Let's go to quotient rule. Quotient rule is used to differentiate fractional functions. Quotient rule is used to differentiate fractional functions. Class, functions that have numerator and denominator. Anytime a function has numerator and denominator, just know that it's quotient rule that will bring it down. Anytime a function has numerator and denominator, know that it's quotient rule that will bring it down. Class, given a function y equals to sin x over cos x, he has to find the y. Class, you call your numerator u. Class, right now for quotient rule, right? Note. Let me give you the step-by-step quotient rule. For quotient rule, you are going to call your numerator u and denominator v. For quotient rule, you call your numerator u and denominator what? V. For quotient rule, you call your numerator. Who is numerator? The person on top, u, and denominator, the person below in the fraction. Every fraction has numerator and denominator. So what this means that my u is sin x and my v is, call your numerator u and call your denominator what? V. Step 1. Step 2. Differentiate u with respect to x, that is the u dx, Differentiate u with respect to x, that is the u. And differentiate v with respect to x, that is the v. Differentiate u with respect to x, that is the u dx. And differentiate v with respect to x, that is the v. Plus differentiate u, differentiate sin x, so you have cos. Differentiate cos x, so you have minus sine. You see, I don't need to explain how I got minus sin x. I'll give you the table, right? Everybody here knows that when sin x is differentiated, you have cos. Low battery. What could be the problem? Hello? Hello? What's wrong with the MTN line? Class. So step 2 said find the UDS and find the UV. Step 3 now said divide the use the quotient rule formula. And now apply the quotient rule. The quotient rule formula tells us that v du dx, that is dy dx, let's start with dy dx equals to v du dx minus u dv dx all over v squared. V du dx minus u dv dx divided by v squared. V du dx minus u dv dx divided by what? V squared. This is the formula for quotient rule. Do not confuse this with product rule. Who can still recall product rule? Product rule is u dv plus v du. There's nothing like all over anything, right? But this is v first before u self. Product rule starts with u dv dx. But this starts with v du. And product rule is plus. This one is. Who is our v class? Cos. Who is our du dx? Another cos. V is cos x, du dx is cos. Minus u, who is our u? Sin x. And who is our dv dx? Minus sin. All over v. So who is v? Cos x. Or now cos x times cos x is cos squared x. Now minus times minus plus sine squared. Plus sin x times sin x is sine squared. But minus times minus is all over cos x, or cos squared plus sine squared is 1 in trigonometry. So you are finished. If you think you are done, you will not see this in the option. Cos squared plus sine squared plus cos x squared should be your final answer normally. But you are not seeing it in the option because cos squared plus sine squared is 1 in trigonometry. It's a rule of trigonometry, and 1 all over what? Cos x, or, and there's a rule I just showed you, I didn't remember, that 1 over cos x all square is sec square. 1 over cos x all square is sec square. Go back to that thing I was telling you, 1 over this, cos x this. Check. 1 over cos is sec. 1 over cos is, so 1 over cos x square is also sec square. For class, I want to remind you of something. Can you look up 1 minute? If I was giving this question in the exam, I will not use quotient rule. I will not use what? Class, I will just know that my trigonometric knowledge will help make me faster than you. I will record that sine over cos is tan. Is what? And anytime tan is differentiated, I do like the table is sec square. Anytime tan is differentiated, check that table I gave. It's not sec square. But you see that the quotient rule still gave sec. Who is faster? That is smart. What's the first step? If you don't know that sine over cos is tan, I give you that, I'm writing it here. In fact, it's like I'll teach trigonometry first in Mat 110. Trigonometry is giving student issues. Sine over cos is what? Change your question from sine over cos to what? And when you differentiate tan, you have also differentiated sine over cos, because sine over cos is tan. Check that table. The differentiation of tan gives you sec. Just one straight root. Meanwhile, see all we need before you get there. Who is faster in maths? Who is the person that will pass that math to? Who is faster in the exam? Who is faster in the... I only went through this process so to teach you quotient rule, because it's not all questions that will be sine over cos. There are some questions that you cannot resolve it to a simple thing and just differentiate. You will need to apply quotient. So I have to use this question to teach you quotient rule. So it doesn't mean that it's all quotient rule question that you must change. Where does sine square x go? Cos square x plus sine square x is 1. That's what I'm saying. Trigonometric rule. Cos square x plus sine square x is a rule of trigonometry. So all this cos square plus sine x has changed to 1. Imagine. How will you ever think that in the exam? You have to practice so many questions because so many things are obtainable in Math 120. There's nothing I will do now, I will change to something else. So there are many things I can change to many things. Let me pause it. I'm recording. Remember. Class, differentiate y equals 2x plus 7 all over 3x plus 1. Differentiate y equals 2x plus 7 all over 3x plus 1. Plus, anytime you see a function in fraction, just know that it's quotient rule that will deal with it. Just know that it's quotient rule that will deal with y equals 2x plus 7 all over 3x plus 1. So it's the classwork. You're putting your hand. Y equals 2x plus 7 all over 3x plus 1. Differentiate. Differentiate y equals 2x plus 7 all over 3x plus 1. If you have anybody writing jam is getting close, April. Direct them to us, let them join our jam class. We'll have a serious jam class for them. If they are not in PH and they're your friend or your brother, they can still learn with us. Yes, we have a group chat for our jam class. They can learn with us. If you're interested after the class, you can see me. It's a private class. It's a private jam class. It's not a general class, so I'm not taking everybody. I have to see that you're serious first. The person is serious and willing to learn. And it must be a science. I don't teach art students. Many of you have directed art students to me and say, please, Andrew, I say, I don't teach arts. Hey, you must have your area of concern. I'm a science-based teacher. I'm a science-based teacher. And I can't be teaching art, teaching science, teaching commercial. No, where are you now? Stand one place. I'm a science teacher. So you have them writing jam, direct them to us. You see their jam score. Just send any jam students to us and watch out. Ask them, what did you score at the end of the jam? Just ask the person. And you will know what's up. Yes. Know the funny thing, I have people in 300 level in my jam class. Someone is in 300 level PSB, she just doesn't like the course, she wants to study nursing. People in 300 level AEB, it's not, I have jam class by 3 o'clock. You see, if you have to see me in my jam class. I have people in 300 level that want to write jam again. I have someone that is in pharmacy year 1 now, she was in 300 level AEB last year. She wrote jam, said she doesn't want this AEB, she wrote jam again. So I'm MCB, they wrote jam again, since I wanted nursing. I didn't get it. I'm not happy. I'm not still happy with this course I'm studying. And this is so says, don't worry, I'm ready to do it. I'll do it. Joy is in pharmacy year 3 now. She started from year 1 again, from year 3. She was already in year 3 AEB. She started from year 1 again. She's in pharmacy now, year 3 back. Said she wanted to study pharmacy. So we have students like that in our class. So if you have anybody taking jam, direct them to us, let us coach them, let us coach. Distance is not a barrier, distance is not a... Class, U is 2x plus 7. V is 3x plus... differentiate u to x, you have du. V to x, you have dv. So differentiate 2x, you have 2. 7 is a constant, disappears. Differentiate 3x, you have 3. 1 is a constant, disappears. You will now say v du dx minus u dv dx, right? Following the formula now. Who is v? 3x plus du dx 2 minus u 2x plus 7 dv dx 3 all over b square. Who is v? 3x plus 1, or 2 times 3x 6x, 2 times 1 this is x plus 2 minus 3 times 2x 6x, 3 times 7 all over 3x plus 1, or use this minus to open the brackets. You have 6x plus 2 minus 6x minus 20, or minus 6x minus times plus minus 21 all over 3x plus 1, or 6x minus 6x 0, right? 2 minus 21 minus 19 all over 3x plus 1, or minus 19 all over 3x plus 1, or square. Class, that's quotient rule for you.